Hello, good morning to everyone. This is Dr.Kausar, Unnisa, Assistant Professor, Department of Commerce and Management, GFGC KGF. So, in the previous classes and all, we have come across regarding to the calculation of different types of measures of dispersion, that is range, mean deviation, and quartile deviation. In this session, we are going to start the last type of measures of dispersion, that is called as standard deviation. This can also be called as root mean square deviation. The concept standard deviation was introduced by Carl Pearson in 1893. It is one of the most important and widely used measure of dispersion. It measures the absolute dispersion of a distribution. Therefore, standard deviation is the square root of the arithmetic mean of the squared deviations of the values from their arithmetic mean. So it is generally denoted by the symbol that is called as sigma. So standard deviations is nothing but the root of sum of the squares of the deviation divided by their number. So it is also called as the error deviation. So it is generally denoted by a symbol that is called as sigma. And the standard deviation is they are useful in judging the uniformity and consistency of the observations. If lesser the standard deviation means more will be uniformity, and it means that less variability, and greater the standard deviation means lesser the uniformity or more variability. So here standard deviation is what is nothing but standard deviation can be calculated very easily by sum of the squares of deviation divided by their numbers. So let us will see some of the differences between the mean deviation and the standard deviation. See, in case of mean deviation, the averages are scatter of the items from the mean or median of the mode. But in case of square deviation, it is a square root of average of the deviations from mean only. In case of mean deviations, algebraic signs are ignored, but in case of standard deviations, algebraic signs are considered. And in case of mean deviation, it is very comparatively easy to compute and understand, but the standard deviation is very tedious and more calculations are involved. So the mean deviation is having lesser utility, but the standard deviation is having widely used. So let us will see how in the case of individual observation or in the case of individual series, how the standard deviations are being calculated. We can able to calculate the standard deviation both in the form of actual mean or by the assumed mean method. So what are the steps has to be followed to calculate the standard deviation of actual mean or by assumed mean means? First, what we should do, we should take the deviations from mean to find out d or dx. We can able to have the deviation with the help of alphabet d or deviation of x. Then what we'll have to do, we should square the deviation, that is nothing but d square or dx square. If you have shown it as dx means we should do it for dx square. If they have shown only d means we can go for squaring the values of the deviation, that is d square. Then we should divide all the sigma d square value by the total number of items. So we can, and we have to extract the square root by using the formula. So this is how we are going to calculate the standard deviation. So let us will see one question here. What is the formula for the calculation of actual mean? Mean standard deviation is nothing but root of sigma x square. So either you can go for sigma x square or dx square is one and the same. Dx square divided by n, where x square indicates the squared deviation from the actual mean. If you are going to calculate with the help of assumed mean means standard deviation is nothing but root of sigma dx square minus divided by n minus of sigma dx by n whole square. Either you can go for d square or dx square are one and the same. Let us will see here the calculation of standard deviation by direct method. Here we have calculated directly. How to calculate in case of direct method means in the case of individual series, the values are given 25, 27, 31, 32, 35. If you are going to calculate in the direct means, whatever the values of the variables are given, it has to be squared. Then 25 becomes 625, 27 becomes 729, 31 becomes 921, 32 becomes 1024, and 35 square is 1225. Then we'll have to total the value of sigma x, that is 150, sigma x square is 4564. If you are not taking with the help of deviations, means this is how we to calculate by the direct method. So standard deviation equals root of sigma x square by n minus of sigma x by n whole square. What is this sigma x square means? Root of 4564 divided by number of items are 5 minus of sigma x is nothing but 150 by 5 whole square. Then root of, we'll have to divide 4564 by 5 means we'll get the value, that is 912.8 minus, first we should divide 150 by 5. Then the value has to be squared, it will become 900. Then the difference of 912 minus 8, 0.8 minus 900 is nothing but root of 12.8. Then remove the square root for 12.8, the value will get, the value of standard deviation is 3.578. So this is how we can able to calculate directly without taking any deviations. And here one more for question, that is already given in the question, n equals 10, sigma x equal 120 and sigma x square values are no need to go for calculation, already given in the question. The same thing has to be substituted and we'll have to calculate the coefficient of variation. If standard deviation is the absolute measure, means coefficient of variation is the relative measure of calculation. Therefore, mean equals sigma x square by n. It is nothing but here they have given, that is 120 sigma x by n for the calculation of mean, that is 120 by 10 is nothing but 12. Therefore, standard deviation is nothing but root of sigma x square by n minus of sigma x by n whole square. So sigma x square value is already calculated, given in the question, 1530 by 10 minus 120 whole square divided by 10. Therefore, we'll get after dividing x square by n is nothing but 153 minus, after dividing 120 by 10, then squaring it, the value becomes 144. Now we'll have to find out the difference between 153 and 144. It is 9. Then remove the square root of 9 is 3. This is the absolute measure. The relative measure of dispersion, the formula is standard deviation by mean into 100. The standard deviation here we calculated 3 and mean value also we have calculated this 12 into 100 is equals to 25. This is how we need to calculate the coefficient of variation. Let us will see one more question here. Calculate standard deviation by direct and shortcut method from the following series and also find coefficient of variation. So here the wages values are given 40, 44, 54, 60, 62, 6, 70, sorry, this is 60, 70, 80, 90 and 96. In case of direct method, we have to calculate the wages has to be written as it is given in the question. Then we should do the deviation. Either we can write it as small x or deviation of x, or we can write d also, or dx also we can able to write for the deviation. So here the deviation of x is nothing but x minus actual mean. So for that reason we require to calculate the value of mean. Now total all the, in case of direct method, mean how to calculate under individual series means mean is nothing but sigma x by n. Here total sigma x value is 660 divided by 10, it is 60. Now we'll have to do all the deviations with the variables with 60. 40 minus 60 is 20. 44 minus 60 So the deviation is 66. Sorry, here the value of mean is 660 by 10. It is nothing but 66. So 40 minus 66 is minus 26. 44 minus 66 is minus 22. 54 minus 66 is minus 12. 60 minus 66 is minus 6. With the help of actual mean, we are doing 62 minus 66 is minus 4. 64 minus 66 is minus 2. 70 minus 66 is plus 4, 80 minus 66 is 14, 90 minus 66 is 24, 96 minus 66 is 30. Then the total of all dx value is, we are getting it is 0. Now we'll have to square it the same. So here 26 square is 676, 22 square is 484, 12 square is 144, 6 square is 36, 4 square is 16, 2 square is 4, 4 square is 16. 14 square is 196 and 24 square is 576, 30 square is 900. Total all the value of deviation square, that is 3048. Now we'll have to apply the formula, that is standard deviation is nothing but sigma x square divided by n. So this is the direct where we are going to calculate with the help of actual mean we have done the deviations. At that time we should use this formula sigma dx square or x square one and the same, or sigma d square is also one and the same. Root of 3048 divided by 10 we will get the after dividing we are getting 304.8. Remove the square root, it is nothing but 17.46 is the value of standard deviation. In case of this is absolute measure. In the case of relative measure, CV is nothing but standard deviation by mean into 100. The value is 17.46 divided by 60 into 100. It is nothing but 29.1%. Let us the same thing, the same question can also be done with the help of what assumed mean method. Here we no need to do the deviations with mean. We can do with the assumed mean value. So wages already given in the question, same thing has to be written here. Then let us will go for calculating the dx column, that is deviation from x. Here among any one variable we'll have to consider one number as 60. So 60 we have taken it as a. So we'll have to do all the deviations. If plus comes, you should write plus. If minus means minus only. 40 minus 60 is minus 20. 44 minus 60 is minus 16. 54 minus 60 is minus 6. 60 minus 60 is 0. 62 minus 60 is 60. 64 minus 60 is 4. 70 minus 60 is 10. 80 minus 60 is 20. 90 minus 60 is 30. 96 minus 36 is 96 minus 60 is 36. Total all the values of deviation, that is sigma dx, becomes 60. Now we'll have to square all the dx values, then we'll get the total, that is sigma dx square is 3408. Now we have to apply the formula here for the calculation, that is standard deviation. In case of assumed mean, we should use this formula. In case of actual mean, we can go for using the formula. Standard deviation is nothing but root of sigma dx square by n minus of sigma dx by n whole square. Then root of sigma dx square calculated already, 3408 by 10 minus 60 by 10 whole square. Then after dividing 3408 by 10, we'll get the value, that is 340.8. 60 by 10, divide it, it will become 6. 6 square is nothing but 36. Then after finding out the difference between 340.8 minus 36, okay, after removing the square root, we'll get the ultimate answer, that is 17.46. This is in the calculation of standard deviation under absolute measure. But in case of coefficient of standard deviation, we require what? The calculation of mean, because the formula is standard deviation by actual mean into 100. So with the help of this only, we'll calculate the actual mean. Mean is nothing but a plus sigma d divided by n. So a means here we have taken 60 plus sigma dx is like sigma d value or dx value is nothing but 60 by 10. We'll get the actual mean value is 66. Now we can able to substitute it in the formula for calculation of coefficient of standard deviation. Then the standard deviation value is 17.46 divided by 66 into 100. The value will be 0.264, or we can write 26.4%. So this is how we are going to calculate the value of standard deviation both in actual and assumed mean method. Let us will see here from the one more question, that is from the following two series in a data which is more consistent. So the mean of A is 40, standard deviation is 5, mean of B is 50, standard deviation is 4. Let us will check which is more consistent in variable. So coefficient of variation of A is the formula for CV, standard deviation by mean into 100. Standard deviation value given already, that is 5 divided by 40 into 100, it is 12.5%. B series standard deviation is standard deviation by mean into 100, that is 4 by 50 into 100 is 8%. So we can able to say that B is more consistent than A, because the CV of B is less compared to A, therefore it is more consistent, and A is more variable. So this is how we are going to calculate the value of standard deviation in case of individual series. With this I am going to end the session. Thank you.